It is actually chemical engineer who judgment. There may be some chemist who might have synthesized that, right? But the mass production of it and the unit in which it is produced, right from every component that goes to produce that bulk production, then putting it into reels, then packaging it, and quite a few of the vaccines are got to be refrigerated. So you develop a unit where actually it is kept cold, and then there is a transportation, refrigeration during transportation, making sure that it reaches there. And when a doctor is using a syringe and a needle for injecting it, that again has got to be produced. So all these things, every way, an engineer in general, most probably the chemical engineer is actually involved in it. So what I'm trying to say is, as a chemical engineer, you do end-to-end engineering. For example, I want to go to Hyderabad from here. Suppose you take a bus and someone drops you at Kurnool, then Kurnool so you can't do that. So similarly, a chemical engineer, you want end-to-end service. That is, from the moment you start the designing or the synthesizing that to the production to the end, where the customer is going to use it. That's what end-to-end engineering, that is actually what, every engineer does it, and the role of chemical engineer is much more dominated. Next slide. So to achieve that one, they must go through a thorough understanding of chemical reactions, separation techniques. Because most probably because you are in first and third year, so some of you might have done reaction engineering, separation techniques. What are various separation techniques? Adsorption, okay? Absorption. Then catalysis, you was reading that. So thorough understanding of chemical reactions, how they, when you produce X plus Y is equal to Z, I want only Z. If X plus Y gives me A, it is not acceptable. So how do I make a chemical reaction where I get exactly what I want? So that is that's a technique you develop with the basic knowledge of chemical engineering. And they often work on designing and operation of plants and equipment in these industries. Let's take, for example, electricity. Okay? The electricity is coming into your rooms. Where does the electricity come from? Possibly one of the thermal power plant like Contiuation, IIChE and this plant. So it may be coming from hydro plants also there. Most probably in Andhra, most of us we get from thermal power, either Vijayawada, Contiuation, Ramagundam. Most probably ours comes from hydro. Anyway, today to tell you that today they have got in the country what is called national grid. It doesn't, you don't know where this electricity is coming from. It could be coming from right from Meghalaya, so we don't know about that. It may be coming from Kalpaka, it may be coming from Tuticorin. So they got the national grid. So all the entire country is one grid. It actually wherever it is required, it is separate there. Okay, when how the electricity is produced, you have got a boiler where water is converted to steam. Steam is expanded in a turbine, and that's all you have studied there. But it's not just as simple as bread and butter. So your boiler has got to be designed. The water you get is actually river water. That river water has got so much of sand, so much contamination. So first and foremost thing, you got to purify the water. So first thing is you do the filtration. Filtration is one of the standard techniques in chemical engineering. Filtration, then water treatment. You got to remove the dissolved gases. You have to remove the dissolved salts. So you got to remove all those things. Then it goes into the boiler. Once the steam is produced in the boiler, then there is a fire and the steam. Then you got to design the boiler tubes appropriately. You produce the steam. Then of course it is expanded in a turbine. Most probably chemical engineers don't have much to do with the turbine. Mechanical engineers, electrical engineers will do that. Then it is connected to a generator, then electricity is produced, then it is transmitted. Then it is stepped down in a transformer. Does the chemical engineer has anything to do with the transformer? What has it got to do with a transformer? What is the role of chemical engineering in the design of a transformer? Transformer is electrical engineering. Some 13 kV or step down to 440 whatever the steps you do. Where does the chemical engineering come in the picture? All of you know that if you have seen the transformers, just show the transformers. If you go and just outside as you enter the campus, before the campus there is a power house there. Then you can see that some tubes will be going there, round and round. There's actually a step down transformer. Okay. So in the transformer, what happens is, they are what we call electrical engineers, they call it, they do some electrical engineering also. You know what are the I squared R losses, heating losses. Because of the heating loss, the transformer gets hot. So there is an oil there inside the transformer. The transformer oil. So what kind of oil you got to use, how much of oil you got to use, okay, and what are its properties, and how it has got to be located, how you design the oil flow path. All these things are done by either by chemical or mechanical engineering. Most probably the transformer oil itself would have been developed and also tailor-made for the transformer. For example, the transformer oil, you can't use it in engine oil. So each oil is different. Though everything is oil, so each oil, that is like they say, horses for horses. So appropriately you have to design. Say for your engine oil, it will be different. For scooter, it will be a different type of oil. For what you want to apply for your hair is a different. What you are cooking is a different oil. So each of these oils, how they are synthesized, then most probably a chemical engineering will be important. And over and above that, what chemical engineering always makes, any engineer generally, we all make sure that safety is very important. Safety is on two aspects of it. One is when during the production process, when I said that end-to-end engineering, from the beginning to end, there should not be any accident, there should not be any death, there should not be any injuries to any person. Of course, the safety is something that is given, it's not given so much of importance in our country, but all over the world, safety is a very important aspect. Whenever something happens in any industry, first it comes in the news, in or any of the Indian news, you all read about it, you just brush it out. By tomorrow you have forgotten about it. That's not so in any other countries. Any one accident, the place where it happens, the person who is responsible for designing that he is the case of chopping down. Most probably he will lose the job if because of his mistake there is an accident. So safety in end-to-end engineering, and at the end of it, when you design a service or a equipment, when it goes on to the end user, the safety of the user. For example, let's say the transformer oil. If you put some kind of acidic in it, someone it spills on someone's skin, his skin will get burnt. So it can't be an oil. I mean, most of the oils are not acidic anyway. But by mistake, there is some contamination is there. Or the way some of the transformers, some of the oils are absorbed by the skin. So that's one. Is there a possibility of combustion? Most of the transformers are burnt. In fact, that's why you have accidents because of transformers. That's why it is got to be completely enclosed, so that there is no exposure to fire or fire hazards. So end user safety is as much important as end-to-end engineering, safety during the process of production. Okay? To do all these things, you need something, you need some resources. I ask you to do something, you say, look, what is it that I have got in order to do that? There are 5 types of resources judged by a law. All of them, this is sheer common sense. There is no engineering in it. First and foremost thing, if you want something, you can't say, your boss can't say, I will tell you in the morning, I want it by evening. No. I need time to design, synthesize, make sure that it is safe. First and foremost, time is the most important resource. Unfortunately, none of you seem to realize that. Professor had told you that you should be coming here at 9:30. How many people did really turn up at 9:30? Tell me, raise your hands. Who came at 9:30 sharp before? 1, 2, 3, 4, 5, 6, 7, 8 people. There may be somewhere pretty close to about 10, maybe 10 people. So 90% of you didn't turn up on time. So let's assume that you all turned up at quarter hour behind the scheduled time. There is one gentleman walking in right now. He doesn't know even much, he knows much less about the value of time. 15 minutes, 100 people, 15 minutes, that is something 25 hours of production last. If we are working and we are paying a carpenter at the rate of, now the carpenters are not cheap, we are paying him at the rate of 600 rupees an hour, that's what they charge in many cities. That fellow doesn't for work for 1 hour, are you willing to forego those 600 rupees? Answer is no. So time is very important aspect of it, and that time has got to be very systematically, very professionally, very efficiently utilized. Time is the most important resource that everyone has, because once you lose time, you have lost it. Yesterday is gone. Tomorrow is yet to come. There's a song on that one. Yesterday is gone. So time, first and foremost thing, if you want to do any of those things, you need time.